We're gonna build your build. So on this video, we're gonna talk a little bit about a Neon engine. I recorded this like 2 months ago. I maybe even 3 months ago, probably even more, to be honest. But I most of you may know I bought a house, I moved a shop. There's been so many moving parts in my life lately, and it's been really hard to record. I have recorded some stuff, and I'd be probably starting sharing a little bit more in the next few weeks. um yeah, I'm just in this video, I'm gonna be talking a little bit about a Neon engine and four-cylinder deal, Dodge four-cylinder, and how underrated they are, in comparison to some engines that are out there. I think it'd be a great performer for guys that are doing sport compact racing. I think it lacks a little bit in the development department, and that's why they're not as far along as, let's say, the Hondas are. But definitely not a bad platform. Just like I said, needs a little bit more development. So I shared this little video, this little snippet. It's not gonna be for everyone, I get it. But there will be more to come. There's some recordings of some racing that I definitely want to share, and a little bit more about the Nova. The Chevette is back. A little bit more on that, and so yeah, enjoy. So my sons are in the shop helping me out, and this 2.4 is actually for my son's car. This one's for customers, and two different applications, but I just wanted to talk real quickly and real briefly about these engines. I think these are some of the best four-cylinder engines that have no real following that they deserve, and I don't know why. Construction wise, they have a bed plate, solid iron block, they're strong, they have good stuff right out of the factory. Where they were limited for boost from the factory, the pre-turbo motors, and this is including the 2-liter as well. They had weak rods. The rods were not as strong. But when they went to the turbo motor, matter of fact, I have a set of rods right here. They went to this type of rod, and people, they make 500 to the wheel with these factory stuff all the time. I'm pretty sure some guys have gone even higher than that. This motor is going together with H-beam rods and forged piston. Same thing with the other motor. Again, two different applications for two different jobs. These motors deserve way more credit though. Just by design, the whole bed plate design makes this thing super sturdy, super strong. I say that one of the biggest limiting factors on these motors, and it's kind of like not worth arguing the point, because you sometimes if you argue with a donkey, you become the donkey, right? So these motors from the factory or aftermarket wise didn't have the biggest cam selection, and we have guys building full-blown race motors or motors that are trying to hit 4-digit numbers with only 215 degrees of duration at 50. And because they're doing that, they need excessive amounts of boost to hit that number, and they make these engines really look bad for sure. The heads ported flow phenomenally. Is it K-series good? No, it's not. It's not the point of a K-series. But is it good compared to other, like a Honda B-series or even H-series? Yes, and even better. You could really make these heads really move, especially with the limited aftermarket support that these motors have. I do have a ported head that's under here. This head, I don't feel like digging this one out. Hold on. Well, maybe I do a quick comparison here. All right. So here's the SRT4 head, and a 2.4 Stratus head. This head advertised. I'm actually gonna flow bench it before I even do anything with this one. They advertised this port job at the time to flow 315 CFM, and it was like a CNC port program that they had. This is going back over 20 years now, but look how small the port is. Now, if this does move 300 CFM compared to 300 plus CFM, compared to other makes and models of engine, look how small the port is to make that happen. You know, compared to, and this is an SRT4 head. SRT4 head actually has a little bit more area to actually make the port even bigger than the previous head. The exhaust valve, I believe, is also smaller though than the naturally aspirated head from the factory. So this head actually had to strip down, and it's gonna go over. It's just gonna get a basic rebuild and a touch up on the valve job. This one, again, this is a race head, you know, and the valve job itself left a lot to be desired. I see that now. You know, younger me, when I was messing and building these neons, I didn't understand or know as much as I do now. And, you know, looking back at this head, like I said, I had this head for, you know, 15 years probably now. The valve job left a lot to be desired. And I think there's ways that you could pick up even more now than was known to be at that time. So my whole spiel with that was to talk about these heads flow plenty of air. If you do basic math, the basic math on how much power these motors can make, just with the head flow, a 300 horsepower naturally aspirated combo is not out of question. And not only that, it hasn't been done before, but there hasn't been that many of them done, and I think it's because of mostly like politics. Like if you go on the old neon boards, you know, a lot of people sought wisdom from, you know, certain individuals, and you know they reached to a certain plateau, and then that's where it stopped. It seemed no one really pushed past that. If you had ideas, they will shoot your ideas down. It's kind of weird if you think about it. When it comes to the Honda world, you know, people were constantly testing and pushing limits, and that's why Hondas are where they're at now. Honestly, that's where they're at. You know, the transmission was also a limiting factor on these, but as an engine, these engines are really, really good, and there's still plenty of room to grow. I could make this port better, 100% better. You know, I'm sure I will get the opportunity in the future to spend some time and actually build something that's gonna really push the barriers. I want my son's motor. This head most likely is gonna go on my son's motor to make real good power, naturally aspirated, and push the limits of what the stock computer can do. I have some ideas. I talked to some people, and Tim, and we might, you know, collab in the future with something that I think would be pretty cool when it comes to the neons. I know my channel, we don't do many 4-cylinders, but this would be a little bit of a little sprinkle this in the future. So let me go back to the block. Now, looking back at the block, you know, this I have it tilted on the side. I'm gonna measure the bores out, and then make sure the piston to wall stick clearance is good, and start filing some rings and stuff like that. But I have it tilted on the side to show one pro about these blocks and one con. So a pro is the oil drain backs. So these holes right here are where the oil drains back to the crank, right? So they follow along the side, the back of the block, right? And there's this similar design. So it goes to the back of the block, and then drains out behind the crank. So with this style of motor, you have way less issues with windage, and you don't have to worry about windage as being a problem as much anymore, just because the oil is draining away from the crank, and the crank, you don't have to worry about the crank whipping up and taking the oil along with it. So you got the oil drain back, which is, you know, a great thing, a great awesome feature that's part of these blocks. And then the big negative. So the biggest negative when it comes to these motors, especially when you go big boost or whatnot, is actually the distance that these head bolts have from the cylinder. So that's why, you know, these eventually warp heads, the block have issues at times. Like this block came off a motor that was running poorly, and long story short, this block needed to get cut. The block I have over here over here needed to get cut as well. So, you know, that's a problem. So and probably the major contributor to that is the distance these bolts have away from the cylinder wall, right? So in higher power situations, there's more space away from the cylinder for things to move. The actual cylinder itself is very thick. I mean, you could go 100 over, no problem. No problem whatsoever. You have plenty of cylinder wall to go 100 over. But the problem is, like I said, the distance you have from the stud to the cylinder. The closer you can get that, the more easier it is to have a tighter sealing surface. So that's a drawback for crazy big power applications. But, you know, properly built with checking the clearances and doing what you're supposed to, these motors should make reliable horsepower more than a lot of other manufacturers. I'm not trying to get to a manufacturer war when it comes to four-cylinder stuff, but this stuff is pretty good compared to what's out there. So, yeah, without going too much of a tangent on anything else, I'll give one more comparison, and I'll let it go with this. So this is Crawler's biggest cam that they offer for the SRT4 application, right? This cam is going to the SRT4 motor. This cam is as big as it gets, as what you could get without getting custom grinds. And I'm pretty confident, I'm going off the top of my head, that a factory VTEC lobe on a Honda, Honda K-Series motor is bigger than this cam. So when we build a naturally aspirated, even a full turbo build, when you're limiting yourself with this much cam, you're making the engine work so much harder to make power. I don't care if it's turbo, I don't care if it's naturally aspirated. If you go naturally aspirated, the Crawler stage 4s, now stage 4 is big, right? Stage 4s, I think, is only 218 degrees at 50. That cam is tiny. The cam is small. I don't care how you measure it. I don't care. That's a small camshaft that you're trying to make engine make power up high. A 2.4, a 2.4 will make peak power under 7,000 RPMs with that cam. And then the factory computer, maxes out at 7,800. That means you literally have more power with the factory computer left on the table with a different camshaft. You're just leaving it. You're fighting yourself at this point. You're using a what would actually be like a torque lobe, right? Now you're limiting yourself also with the factory computer. I understand the factory computer is kind of the limiting factor. The more low separation, the tighter that low separation gets, that's the more lope you get, and the less vacuum that map sensor sees, the factory computer is gonna get a little funky with you. But if you get a cam card and you degree the cam and you move the lobes out and get it away from having too much overlap at the lower point and have tons of reversion, that's why, you know, you take a lot of Neon motors apart. Now this one has miles and is a stock application, but they all look like this. You know, even 5,000 miles and it all looks super cooked up. A lot of that is because of reversion, and you don't have enough exhaust flow to get everything out, so everything is coming back in and backing in and into the port, and you're running again, going to the naturally aspirated side of things. You got 13 to 1 or 12.5 to 1, and you put a crawler stage 4 cam, thinking stage 4, right? Stage 4 is the biggest, baddest thing. So stage 4, you're literally running a street cam, or literally is a street cam. The cam is tiny. If I showed this cam to any reputable Honda builder for a race application, they would laugh. It'd be comical. I'm gonna reach out to a respected Honda builder, and I'll see if I could input our conversation in this video, and why I could guarantee you he's gonna look at these numbers and laugh. It's gonna be a joke, because you're literally fighting yourself by running cams this small. If you're gonna race one of these motors, don't use this. Do not use cams this small. You're gonna have to get them custom ground. You're gonna need a lot more duration than this, but I promise you, you're gonna make much more power. The thing's gonna go much faster, and you're gonna make the power with less boost. That's the idea. I don't care if you're building a motor naturally aspirated or with turbo. Naturally aspirated or a turbo motor, I don't care. The most power you can make naturally aspirated, the more power is going to make under boost too. So if your application is to let's say if you want to make 400 horsepower, right? If you can make 200 wheel horsepower naturally aspirated, or 200 horsepower naturally aspirated easy, then it only take 1 bar of boost to double that output. So you can make 400 horsepower with about 14 psi with the proper size turbo, right? Or even more, you know, depending on how efficient you make the application. You could actually go even more than that rule of thumb. So a lot of guys need a ton of boost to make horsepower because they don't have the right combination of stuff altogether. End of rant, end of tangent. This is where I'm gonna stop this video. I'm gonna have some more normal content. Normal content being, you know, V8 oriented stuff. But I really needed to get this off my chest. I think this platform deserves a little bit better. I think it deserves a little bit better look at. I think guys will continue to go faster with it if they just push the envelope a little bit more and are willing to, you know, not conform. Stop conforming. Stop following. Try to do a little bit of experimenting. Find some different combinations and stuff. You're gonna make a lot more power. The thing's gonna fly, and you're gonna surprise a lot of other manufacturer stuff. Honda, Nissan. We could have a neon powered vehicle competing with them once again, you know, like they used to years in the past. So, build your builds, like, share, and subscribe. Tangent over. Until the next one.
Just keep the clutch in.